Hey everyone! In this video, we're going to be talking about the derivative of a function. We already know one method for finding the derivative. Well, in this video, I want to take a look at a second way we can do that. So let's start off with just a sketch of a function again. So let me put some curve on our graph, and this is going to represent f of x. And remember, what we're trying to find, we want to find the tangent line at a specific point on our graph. So let's say that this is C. On our function, we have this point here. So then the tangent line at that point is going to be the one that touches it in exactly one spot, like this. The way that we thought about this before is we picked out another point somewhere on our function, and we said that this was maybe at x. So here, this point is going to be at C, and then the function value at C. And then we'll say that this one is Q, and then so this was X, and then the function value at X. And that gave us a secant line. So putting in the secant line looks something like this. And then we wanted to move this second point. We wanted to move Q closer and closer to point P. And the way we did that is with a limit. So we took x and we brought x closer to c. So what we ended up with for our derivative, we have f prime of c. So using the prime notation, this was equal to the limit as x approaches c of this slope formula. So f of x minus f of c divided by x minus c. So that limit is taking this x value and moving it closer and closer to c. Well, now I want to take a look at a second way that we can find this derivative. This is going to go back to the difference quotient. So I want to start with just this expression for the slope. And what I'm going to do is I'm going to let x equal c plus h. So now our x value, instead of just calling this x, we're going to call this c plus h. And what that means is that this difference here, the distance in between these two x values, is h. So then up here, this is going to be the point. We have c plus h, and then the function value at c plus h. Okay, so now let's take this c plus h, and let's substitute this into this expression for slope. So instead of x, we'll have f of c plus h minus f of c. And then this is going to be over. And now again, instead of x, we have c plus h and then minus c. And then simplifying, we end up with f of c plus h minus f of c. And then in the denominator, the c's cancel out, and this is just over h. And this is what we called the difference quotient. So now, doing that little bit of substitution, we end up with a new limit. So now we have f of c is going to be equal to the limit. And instead of the limit as x approaches c, now what we want is we want this value of h, we want this to become 0. So in the same idea that we want to take x and move x closer to c, well, here we want this distance in between these 2 points. So we want h to get closer to 0. So h is going to approach 0, meaning the same thing. These 2 points are going to get closer together. And then we have our new expression here, our difference quotient. So this gives us a second method of finding the derivative. And written in this form, this is actually what we want to use when we want to find the general equation for the derivative. So another way I might write this is I would say f prime of x, so the derivative at x, is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. And this gives me a way to find a general form equation for that derivative. Now let's use this in an example. Let's try this out. So here I have f of x is equal to x squared minus 5x, and I want to find the derivative. just in general, I want to find f prime of x. So what this is going to be equal to is the limit as h approaches 0 of f of x plus h minus f of x all over h. So what I like to do, just to start off with, over here is a little bit of scratch work. Let's find f of x plus h right away. So instead of x, we'll substitute in x plus h. So we have x plus h squared, and then minus 5 times x plus h. And this is a familiar process we did with the difference quotient. So we have a binomial squared, so we get x squared plus 2xh plus h squared, and distributing the 5, we get minus 5x minus 5h. So just having that there, so we can easily plug everything in. So now we have our limit as h approaches 0. So f of x plus h is that big long expression we just found. And then from that, we're going to subtract our original function. So we're going to subtract x squared minus 5x. And this entire thing is all over h. So we do have some things that are going to cancel out in that numerator. So we still have our limit, the limit as h approaches 0. And if we take a look, we have a positive x squared, a minus x squared. We have a negative 5x. Distributing the negative, we have a positive 5x. So let's see what we're left with. So we have a 2xh, and we have an h squared, and we're left with a minus 5h. And this is all over h. Okay, looking at this expression, we cannot just plug in 0 for h because we'd end up with an indeterminate form, so we need to try and simplify. Looking at the numerator, all of those terms do have an h in them. So let's start by factoring out that h. If we do that, we're left with 2x plus h minus 5. And we're still dividing by h. And now factoring that out, these h's will simplify. And once they're simplified, now we can actually evaluate our limit. So f prime of x is equal to the limit as h approaches 0 of 2x plus h minus 5. And plugging in 0 for h, this will just go away. So our derivative, f of x, is equal to 2x minus 5. So here we end up with this general form equation. Now this equation, this is going to allow me to find the slope of the tangent line at a certain point. This would allow me to find the instantaneous rate of change at a certain value, or it allowed me to find the velocity at a certain point. So this is just another way that we can find the derivative of a function.